Yes, good afternoon everyone. Yes, good afternoon everybody. Good afternoon. Good afternoon. Good afternoon. Vector calculus. So in the previous class we had a brief idea about the vector calculus. Okay, so what we are going to do, right? What is a vector? What is a scalar? So we had a brief idea about it. Let others also come. And I gave you a question in the previous class. The question was f of x comma y is equal to x square y square 1 minus x minus y. So we have to test it for maxima or minima and we have to find the values. So how do we do it? Let us say that z is equals to x square y square 1 minus x minus y. You further solve it, x square y square minus x cube y square minus x square y cube. You determine dou z upon dou x. Dou z upon dou x will be equal to 2 times of x y square minus 3 times of x square y square, okay, and minus 2 times of x y whole cube. You determine dou z by dou y. Dou z by dou y, it will be equal to 2x square y minus 2yx cube and minus 3x square y square equal to 0. With the help of these two equations you get some values of x and y. Okay, you can take xy common from this. Okay, if you take xy common from this, xy square, to be more precise, xy square common from this, x and x square y common from this, you will get a statement. You get the values of x and y and again do the same thing, that is determine dou square z upon dou x square, which is your r, dou square z upon dou y square, which is your t, and the dou square z upon dou x dou y, which is your s, and determine the values. Okay, determine the values and check whether rt minus s square is greater than 0, equal to 0 or less than 0. You determine these values and you will get the conclusion. Okay, and see the value of r also. So these values we have to determine at the critical points, right? Again at the critical points, these values. So let's move forward. Okay, almost most of the students have come. Okay, so now let's move forward. Now let us start with the gradient of a scalar function. In the previous class also we discussed it a little bit, the gradient of a scalar function, but now let us discuss it completely, the gradient of a scalar function. So what does a gradient tell you? Gradient tells you about the normal vector which is perpendicular to a surface f. That is the meaning of gradient. So it gives you a normal vector to that particular surface. Gradient. Before gradient we discussed about the del operator, right? We discussed about the del operator. It is just an operator, okay? So that is dou upon dou x I vector plus j cap dou upon dou y plus k vector or k cap divided by dou upon dou z. So we discussed about the del operator in the previous class. This is the del operator. And we discussed about the gradient also. So you want to determine the gradient of a scalar function f. Scalar function f, then gradient of the scalar function f is given by del f or grad f. Grad f, right? Both are the same thing. In some books you will find grad f is written, in some books directly del f will be written. So both have the same meaning. So that will be equal to I vector dou by dou x of f plus j vector dou f upon dou y and plus k vector dou f upon dou z. So this is the number one use of gradient. The number one of use of gradient is that it is used to determine the normal vector, right? So uses of gradient. So first use of gradient is that it is used to determine the normal vector to a surface. Normal vector to a surface. If you know the normal vector, you can also determine the unit vector also. You remember? You can determine the unit vector. So we know that unit vector, let us say unit vector is n cap. N cap is equals to the n vector divided by the modulus of n vector. That is the unit vector. Okay, you can also determine the unit vector if you know the normal vector. Another function of gradient is it is used for the determination of directional derivative. Directional derivative of a function. Derivative of a function. Directional derivative of a function. Okay. Now the question is, sir, what is this directional derivative? See, the directional derivative is given by directional derivative. So directional derivative of f vector or of any vector, right? Directional derivative of any vector is equal to grad f dot n vector divided by n vector, or you can also say that grad f dot n unit vector, or you can also say that grad f dot, this is the dot product, right? Dot n unit vector. That is the meaning of grad f. Now the question is, sir, what is the physical significance of you can say directional derivative? See, the physical significance of directional derivative is that it basically tells you that, for example, a particular surface is there. Okay, with the help of grad f, you get the normal vector to that surface. Now one vector will be given to you, some n vector will be given to you, which will be parallel to that particular vector. Okay, now how much is the influence of this vector which is perpendicular to the surface, right, to the direction of this vector, which is also called as the n vector? We will solve some numericals, then you will get how do we approach the questions in which directional derivative is supposed to be determined. Okay, now the question will be like this. Okay, for the surface f will be given to x square plus y square plus z square is equal to something. Okay, the directional derivative in the direction of some vector will be given to you, 2x cap plus 4y cap plus 3z cap, okay, will be. So it will be given to you, the directional derivative will be what? So 4 options will be given to you and we have to determine the correct option. So we'll solve the question, then you will understand what is the meaning of directional derivative. Okay, so gradient is used for the calculation of two things. First one is the normal vector to a particular plane, and second one for the calculation of directional derivative of a function. That is the use of gradient of a particular function. Now let us proceed with some numericals. And dot product you already know. If a vector is given, b vector is given, how to calculate a dot product? a1 b1 plus a2 b2 plus a3 b3. In the previous class also I told you that. Question is, the unit vector normal to the surface, the unit vector normal to surface is given as x y cube z square equal to 4. X y cube z square equal to 4 at points minus 1 minus 1 2 minus 1 comma minus 1 comma 2 will be option number A minus 4I cap minus 12J cap and plus 4K cap. Option number B, minus 8I cap minus 12J cap minus 8I cap minus 12J cap plus 4K cap. Option number C, I plus J plus K, I plus J plus K divided by under root of 42, under root of 42. And option number D, minus I minus 3J minus I minus 3J and plus K cap divided by under root of 11. Divided by under root of 11. So these are the four options given to us. The question is the unit vector normal to the surface x y cube z square is equals to 4 at points minus 1, minus 1 and 2 will be what? Let me rub that. Let me make you explain what is the meaning of that. See, in vector calculus, now it is very easy. In vector calculus, when we will be moving to the surface integral, moving to the volume integral, Gauss divergence theorem, try to imagine the surface or try to imagine the plane, because now we are slowly moving towards the three-dimensional vector calculus. Okay, so try to imagine the surface. For example, this surface is given xy cube z square is equals to 4. So I can write this surface as phi is equals to x y cube z square minus, I can write this surface as this. Okay, now let us try to let us say that this is your z axis, this is your y axis and this is your x axis. This is the y axis, this is the x axis. So there is some surface, because it is written that surface normal to the surface. So there is some surface, let us say there is a surface, some surface is this, which is represented by this function, the scalar function. I told you that a particular scalar function always represents the surface. Okay, so that represents the surface. Now the unit vector, so we have to find a unit vector which is normal to this surface, which is actually perpendicular to this surface at the point minus 1. So these are the point which is minus 1 comma minus 1 and comma 2. So we have to find a unit vector. So we know that, first of all, we know that if you want to determine the unit vector, so unit vector will be equal to this vector, let us say this is your n vector, divided by the magnitude of this n vector. We know that the unit vector of this will be equal to n vector divided by the magnitude of this n vector. Okay. Now there might be a question, sir, what is the meaning of unit vector? See, unit vector is a vector whose magnitude is 1. It just represents the direction of a particular function. It just represents the direction of a particular function. For example, let us say that I am saying you Ram was running at a speed of 30 kilometers per hour. 30 kilometers per hour. Ram was running at a speed of 30 kilometers per hour towards north 30 degree east. If I say you that Ram was running with a speed of 30 kilometers per hour towards north 30 degree east. Let us say that this is your north, this is your east, this is your south, this is your west. So north 30 degree means with north at an angle of 30 degree and towards east he was running at a speed of 30 kilometers per hour, 30 kmph. If somebody asks you what will be the unit vector, right? So your unit vector for this particular will be, you separate this 30. So unit vector will be 1 kilometer per hour at 30 degree towards north, northeast, towards north. This will be the unit vector. Okay, now just try to understand. I have separated the magnitude now, okay, because now if you will multiply it with the magnitude, you will get the exact quantity. But I have separated the magnitude. I am just telling you that he is running with 1 kilometers per hour. Magnitude I have taken as 1, okay. because unit vector, the magnitude of unit vector is 1 unit. Okay, he is running at a speed of 1 kilometers per hour towards this, but that is not correct, because if you will multiply it with magnitude, which is a 30, then you will get the exact quantity. So that is the meaning of unit vector basically. Okay, बहुत ही लेमन टर्म्स मैंने आपको समझा दिया चीज कि क्या मतलब है यूनिट वेक्टर का. Okay, so first of all we have to find the normal vector, right? So normal vector can be easily determined with the help of grad f. So f is your x cube sxy cube, z square minus 4 is your f or phi. Let us say it is f, so that you don't get confused, it is f. Now grad f, grad f, or you can also say del f. Del f basically gives me this vector. Let us say this is your n vector. It will give me n vector. N vector is how much? Grad of f, that is I cap dou upon dou x xy cube z square minus 4 plus dou upon dou z j cap xy cube z square minus 4 and plus k cap dou upon dou z. So this is dou upon dou y, not z, this is dou upon dou y, dou z x y cube z square minus 4. So we will get the n vector which is normal to the surface. Dou upon dou x will be equal to y cube z square z square I vector, or I cap also, some people are saying. Dou upon dou y will be equal to 3 y square x z square, that is your j cap, and plus k cap will be equal to, with respect to z, it will be equal to 2 xy cube z k cap, because the partial differentiation of a constant will be equal to 0. So this is the normal vector, right? So you will get the normal vector this also. So every point of time, if you will keep on changing the value of y and z and x, you will be getting the different normal vectors at different locations. But the location which is given here is that -1 into. So we have to find the normal vector at this position. So if you put these values, so it will be equal to -1 cube multiplied by z square, that is 2 square I vector, plus 3 into -1 square into x into z. X is -1, z is 2. -1 and z is 2, j cap, and plus 2 into x is -1, y is -1 cube, and z is 2 k vector, or k cap. So 2 into 2 is 4. So 4 into -1 whole cube is -1. So it will be equal to -4 I cap. It will be equal to -4 I cap. मैं यहाँ से सीधा यहाँ चला गया, ठीक है ना? यहाँ से सीधा यहाँ. So -4 I cap plus 3 into 2 is 6, minus is plus, and -6 j cap. -6 j cap, and 2 into 2 is 4, minus and minus is plus 4 k cap, plus 4 k cap. This is what the normal, this is what the total vector will be, which is normal or perpendicular to the surface. So I have got this normal vector n. Now I have to find the unit vector. So unit vector will be equal to normal vector divided by the magnitude of normal vector, right? So it will be equal to, the unit vector will be equal to n vector divided by the magnitude of n vector. So it will be equal to -4 I vector minus 6 j vector plus 4 k vector or k cap divided by under root of 4 minus 4 square plus minus 6 square and plus 4 square. I hope that you do not have any doubt in how to calculate the magnitude, by the way, right? So I hope that everybody knows how to calculate the magnitude of a particular vector, okay? So if it is a1 I cap plus b1 something under root of a1 square plus b1 square plus c1 square. So if you solve it, you will be getting minus 4 I cap minus 6 j cap plus 4 k cap divided by under root of 16 plus 36 is 52. 52 and plus 16 is 68, I guess. Let me check it again. 4 is 16, 36 and 16, 8. Yes, 68. So under root of 68. Under root of 68. Okay. So is any option matching with me? Minus 4, minus 12 and plus 4, minus 8, minus 12. So nothing is matching. So I have to do one thing, that I have to solve the denominator, which is under root of 68. So under root of 68 will be equal to 68. So 2 into 3 is 6 and 2 into 4 is 8, 2 into 7, right? So it will be equal to 2 root 17. It will be equal to 2 root 17. If I have not done the wrong calculation, it will be equal to, let me check it here. It will be equal to, n unit vector will be equal to minus 4 I cap, minus 4 I cap, minus 6 j cap and plus 4 k cap divided by 2 root 17. 2 root 17 and 2 gets cancelled out. It will be equal to minus 2 I cap, minus 3 j cap and plus 2 k cap divided by under root of 17. Divided by under root of 17. This is what I am getting, okay. 2 into 3 is 6. 2 into 3 is 6. But this is not matching with the option. It means that I have done some calculation mistake. Can anyone tell me which calculation mistake I have done? I feel that I have done some calculation mistake here. I feel that, okay. Can anyone tell me which sir, it is minus 12 j cap. Minus 12 j cap. Okay, मैं एक बार check कर लेता हूँ. 3 into 2 is 6. 3 into y. Oh, sorry, z square. Okay. Sorry, z square it is. Okay. It is z square, sorry. If it is z square, it will be equal to 2 into 2 is 4. 4 into 3 is 12. And we have a negative sign here. So minus 12 j cap. Yes, very good. It is minus 12 j cap then. Minus 12 j cap. If it is minus 12 j cap, minus 12 j cap. Okay. It will be 12 square here. Minus 12 square here, which will be 144. Minus 12 square here. So it will be equal to 4 into 4 is 16 into 2 is 32 plus 144. 32 plus 144. 32 plus 144 will be equal to 176. Will be equal to under root of 176. And under root of 176 will be equal to, under root of 176 will be equal to 176. See, if somebody do not know how to calculate the under root, right, there is nothing to shy. So whatever I am doing, try to see it. So 2 into 8 is 16. 2 into 8 is 16. 2 into 4 is 44, right? 2 to 4 and 2, 1, 1. So 1 pair and 1 pair, it will be 4 under root 11. So this can be written as minus 4 I cap minus 6 j cap plus 4 k cap divided by 4 under root of 11. 4 under root of 11. Okay, 4 under root. Oh, sorry, again I am writing this 6. It is not 6, it is 12. It is 6, not 6, it is 12. It is 12. Okay, so taking 4 as common, so it will be equal to minus I cap minus 3 j cap and plus k cap divided by under root of 11. Divided by under root of 11. So I feel that D is the correct answer. D is the correct answer. हाँ ठीक है माइनस 12 ठीक है हाँ वही मैंने गलती कर दिया थोड़ा सा ठीक हो जाती है गलती कैलकुलेशन ठीक है ना अब मैं तो डेली क्वेश्चन सॉल्व नहीं करता ना प्रैक्टिस नहीं है मुझे आपको तो प्रैक्टिस है तो आपकी गलत नहीं होना चाहिए Okay, so that is how we calculate the unit normal vector. So D is the correct answer of this particular question. Let us move forward. Let us solve one more type of question. The question is directional derivative of this. Okay. Yes, D. Very good. D. Yes, very good. डी 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 डी, यस, वेरी गुड वेरी गुड। चलिए आगे बढ़ते हैं इसको। शैल आई रब दिस? बोर तो नहीं हो रहे? दिवाली आ रही है कि चलो दिवाली आ रही है तो क्या पढ़ा रहे हैं सर मैथ्स? देखो दिवाली पे ना मतलब ज्यादा काम करना चाहिए। आपने एक चीज देखी होगी, दिवाली पे जो एम्प्लॉयज लोग होते हैं, तो दिवाली पे एम्प्लॉयज लोग क्या करते हैं, सबकी छुट्टी होती है, सब घर पे एंजॉय करते हैं। लेकिन जो बिजनेसमैन होते हैं दिवाली पे, उनको पता है कि दिवाली पे ही मेरा बिजनेस ज्यादा चलता है, तो वो रात को 10-10 बजे तक दुकान खोल के रखते हैं। ठीक है ना? ऐसे यहाँ पे भी है। यहाँ पे ना छोटी छोटी मेहनत जो होती है ना, वो डिफरेंस पैदा करती है गेट एग्जाम में, राइट? स्मॉल स्मॉल हार्ड वर्क, स्मॉल स्टेप्स, they create a lot of difference. So for example, in Diwali, most of the students, right, I don't know how much percentage, but most of the students will be busy in, you can say, other stuffs, okay, decorating homes, okay, and buying some sweets or moving to some relatives house, okay. So they will be busy somewhere, okay. So they will waste around 3 or 4 days, 5 days. So 1 week is almost lost because the zone is changed, okay. For example, you are studying something, but when you are, you can say, away from the zone is changed. So around 1 week will be lost. So this 1 week will create a lot of difference. This 1 week will create a lot of difference. Let us say that if you study just for 5 hours a day, so 5 into 7 days, 35 hours. So there will be a difference of 35 hours in your preparation and the other students' preparation. So these are small steps, they create a lot of difference between you and other people. चलिए आगे बढ़ते हैं। पर ऐसा नहीं है कि दिन भर बैठ के पढ़ना ही है, कि बाकी दिन तो पढ़े नहीं, सिर्फ दिवाली पे पढ़ रहे हैं, ऐसा भी नहीं है। एंजॉय भी करना, लेकिन हाँ अपने स्टडी से थोड़ा ज्यादा दूर मत जाना, ठीक है ना? एक ही साल की बात है, अगले साल से खूब एंजॉय करना, IUCL ONGC जहां पे भी जाओगे। Question is, the directional derivative of f of xyz equal to xy cube plus yz cube, xy cube plus yz cube at 2 minus 1 1, 2 minus 1 1 will be, let me check the options also, okay. Options are, just wait a second, options are the directional derivative, yeah, the options are option number A, root 17 by 2, option number B, root 7 by 2, option number C, root 11 by 2, and option number D, none of the above. None of the above. So we have to find the directional derivative of f of xyz, which is xy cube plus yz cube at 2 minus 1 and 1. Let me check the answer again. Question again. Xy cube plus yz cube at 2 minus 1 minus 1 in the direction of the vector. Yes, I forgot to mention this. In the direction of the vector. In the direction of vector. In the direction of vector I plus 2j plus 3k. I plus 2j and plus 3k. I plus 2j plus 3k. Solution. You try to solve it. What is the formula for directional derivative? So directional derivative, okay, so directional derivative of any function f or f, whatever you want to call, is grad of f dot product n vector divided by magnitude of n vector, or it is also known as grad of f dot product with the n unit vector. It is also known as like this. Okay, so you have to find the directional derivative of this. That is a number 2 application of a gradient of a function. First application is it is used for determination of normal vector, and second it is used for determination of directional derivative of a particular function. Solution. First of all, let us calculate the grad f. So grad f will be equal to del f, and it will be equal to I cap dou upon dou x plus j cap dou upon dou y plus k cap dou upon dou z into f. F is how much? F is your xy cube plus yz cube. So it will be equal to dou upon dou x will be equal to y cube only, y cube I cap, okay, y cube I cap, and that will be 0 plus dou upon dou y would be equal to, is it x cube y or xy cube? Xy cube, sorry, xy cube. So y cube I, and now with respect to y it will be equal to 3xy square and plus z cube into j vector and plus with respect to z this will be 0, and this will be equal to 3 times of y into z square into k cap. This is what the vector will be, but it is a point, so we have to find this grad f at a point which is 2 comma minus 1 comma 1. So 2 comma minus 1, so minus 1 is minus 1 whole cube I vector plus 3x, 3 into 2 into minus 1 whole square and plus z cube. Z is 1 whole cube into j cap and plus 3yz square. So that is your 3 into y is your minus 1 and your z square. Z square is 1 square into not dz into k cap, So that will be equal to minus I cap, and 3 into 2 is 6 plus 1 is 7. Let me again check it. This will be positive. 3 into 2 is 6 and plus 1 is 7. So plus 7 j cap and plus it will be minus, because 1 square into minus 1 is minus 1, minus 3k cap. Minus 3k cap. This will be the grad f. This is the grad f. Clear? Now the n vector is given to us as I plus 2j and plus 3k. So it depends on us. What do we want to do? First of all, we want to calculate the normal vector or the unit vector. It depends on us now. So it can be written as the directional derivative of f is equal to minus I cap plus 7 j cap minus 3k cap dot I cap plus 2j cap plus 3k cap divided by magnitude of the n vector. So magnitude will be equal to under root of 1 square plus 2 square and plus 3 square. So if you take the dot product, it will be equal to minus 1 plus 14 and minus 9 divided by under root of 2 into 2 is 4, 4 into 9 is 13 and 14. 14. Yes, 14. And it will be equal to 4 divided by under root of 14. So 4 divided by under root of 14 will be what? 2 into 7. So 4 upon root 14 it will be, right? It will be 4 upon root 14. So let me check it. Let me check it. So if you do this, it does not match with any of the options, right? It is not matching with any of the options. Let me again check it. 17 upon 2. 17 upon 2. Root 7 upon 2. Root 7 upon 2. Okay, root 7 upon 2. Let me check it. So if it is not matching, it will be none of the above. If it is not matching, it will be none of the above. But let me check it again whether we have done some mistake or not. That is minus 1. It will be minus 1 plus 14 and minus 9. Minus 9. Minus 9 will be this much. Okay. So it doesn't seem that it is matching with any of the options. Let me see the answer also of this question. Let me see the answer. So grad f is coming out to be minus I cap plus 7j cap and minus 2k cap. Minus 2k cap. Minus 2k cap. How is it minus 2k cap? Grad f is coming out to be I cap plus 7j cap minus 2k cap. How can it be minus 2k cap? Have I done any mistake with respect to z? It will be 3z square. 3z square. 3z square it will be. Even if you put it as 2, it will be 6 and 7. Then it will be equal to root 7 by 14. 7. Then it will be root 7 by 14. I guess that there is some mistake because in answer it is written that it is 2k cap. It can only be 2k cap if and only if it is z square. If it is z square. But in question it is given z cube. It cannot be z cube, right? Because I have directly the answer is written, that is minus 2k cap is written. So if it is minus 2k cap, it means that this has to be z square. This has to be z square, okay? So if this is z square, nothing will change. It will be 1 itself. It will be z square, nothing will change. If it is z square, if it is minus 2, then it will be minus 6. Let me check it. If it is minus 2, then it will be minus 6 and it will be equal to 7 and 7. Then it will be 7. It will be 7. So it can be written as 7 upon 2 root 7 and it can be written as root 7 upon 2. Root 7 upon 2. Okay, answer is also given as B. So if answer is given as B, it means that in the question it has to be square. It has to be square. But it is written as cube, so there might be some misprint, okay? So it is a square. So if it is a square, this has to be square here. This has to be square here. If this is a square, this will also be square. But that will not change the result because it will be getting 1 square is 1 itself, okay? It will be equal to, square will be equal to 2z then, 2yz. 2yz. So 2yz will be equal to, here it will be 2 into y into z. So z will be equal to only 1. It will be then minus 2. It will be then minus 2 here. Minus 2 here. Okay, minus 2 here, and then we will get the solution. So it will be minus 2 here then. Minus 2 here, and then we will get the solution. Okay, so there might be some misprint, okay, in the book. बी का रेसिप्रोकल होगा. हाँ, थोड़ा सा मिसप्रिंट है बुक में, ठीक है ना, थोड़ा सा मिसप्रिंट है, तो हमारा तब जाके आपका आंसर आ जाएगा. ये बस को करेक्ट कर देता हूं मैं. पेन है क्या? ये रहा पेन. क्वेश्चन नंबर 23, yz square. Okay, let me correct it also. Okay, done. Yes, otherwise D was the correct answer. Otherwise D was the correct answer, but I feel that there is some mistake in the question, so that is B is the correct answer. Yes, very good, very good, very good. थोड़ा सा मिसप्रिंट था उसमें बुक में, ठीक है ना, मैंने करेक्ट कर दिया उसको पेन से. But I hope that you have got it, how to calculate the directional derivative as well as how to calculate the gradient of a particular function. Okay, and now I hope that you have got the meaning of this. So directional derivative is coming out to be a scalar quantity. What does it mean? Directional derivative basically means that the gradient of a function has how much influence on the unit vector of a particular function. It has how much influence on it. Okay, practically for electrical engineers, if somebody of you might be from electrical engineering background, he must be knowing that this this divergence is basically used for the calculation of electric flux. For the calculation of electric flux, this particular directional derivative is used for the calculation of flux of electric field. Next one is divergence of a function. Divergence. So divergence of a function, of a vector function f, is given by del operator dot f. Del dot f, right? So if f is a vector function, then divergence of f, which is written by div f, is equal to del dot f, and is a scalar quantity, and is a scalar quantity. So let us say that your f was equal to f1 I cap plus f2 j cap plus f3 k cap. Clear? Then the divergence of f will be equal to del dot f. It will be equal to, because del is your I cap into dou upon dou x plus y cap into dou upon dou y and so on. So your divergence will be equal to dou f1 upon dou x plus dou f2 upon dou y plus dou f3 upon dou z. Now let us come to the physical meaning of divergence. Physical meaning. Physical meaning of divergence. The physical meaning of divergence is that, okay, chalo theek hai, to bookish knowledge ho gaya, this was a bookish knowledge. Now the physical meaning of divergence is that it basically tells you, for example, I'm talking about, let us say fluid. It basically tells you how much of fluid has generated per unit area from a particular section. For example, let us say that this was a elementary volume I have taken, elementary section or a control volume I have taken, a small control volume I have taken. Fluid was coming from this direction with the velocity v. Let us say it with the velocity v, fluid was coming from this direction. Okay, and the fluid of the rate of fluid was, let us say that rate of fluid was 5 meter cube per second per meter square. This was the rate of fluid. So per meter square I have calculated the rate of fluid from this. Let us say this is your A, this is your B, this is your C, and this is your D. Fluid was coming from this, okay, but something happened here, and it is a compressible fluid, by the way. It is a compressible fluid. Something happened, the fluid got compressed, or something happened, but the rate of exit of fluid was not equal to 5. Let us say it was equal to 4 meter cube per second per meter square. The rate was not equal then. Okay, now if you convert this fluid, the movement of this fluid into a vector quantity, then you will be getting divergence of the velocity function of this fluid. Divergence of the velocity function of this fluid per unit area will not be equal to 0. Will not be equal to 0. So basically, divergence tells you that from this particular area, how much fluid is emerging out per unit area. How much fluid is getting generated per unit area from a particular control volume. If I talk about fluid mechanics. Now your question can be, sir, why are you always talking about fluid mechanics? Give me some other example, I want to understand it. See, let us say that on earth, let us say now we are standing on earth, I am standing on a plane surface. At any point of time, the sun rays, they are coming on earth. Okay, for example, this is my earth, I am standing here, okay, and this is sun. So some sun rays are coming always on earth. When sun rays come on earth, some amount of sun rays get absorbed by the earth itself, some get absorbed by the trees, the plants, okay. So there is a lot of wastage, and some gets reflected back. Some rays gets reflected back also, and some rays get absorbed. So this divergence is basically used for the calculation of the solar influx. For the solar influx, कि कितना रेज मेरा आया, कितना रेज अर्थ पे एब्जॉर्ब हो गया और कितना रेज जो है रिफ्लेक्ट बैक हो गया. So this divergence function is basically used for the calculation of the solar radiation influx. If somebody is saying you that the divergence of a function is 0, divergence of a function is 0, it means that, so whatever the flux has entered the earth's surface, equal amount has got reflected back. Nothing is absorbed by the earth's surface. Similarly here also, if somebody is saying you that the divergence of a velocity vector is 0, okay, then it means that if it was coming with 5 meter cube per second per meter square, it will be 5 itself. And that type of vector for which the divergence is 0 are called as the, in case of fluid mechanics, are called as incompressible fluid. In case of fluid mechanics. In case of mathematics, those vectors are called as the solenoidal vectors. Let me write it also. So if divergence of a function is equal to 0, in fluid mechanics, those vectors are called as the incompressible fluids, or you can say incompressible fluids, okay. But in mathematics, because we are dealing with vectors, right, in mathematics these are called as the solenoidal vectors. Solenoidal vectors. Solenoidal vectors. Okay, जा रहे हो? कब आओगे फिर आप? So y unit per area, but not total, because see the total area, because when you will go with the total area, it is very much unbalanced. For example, if I talk about Earth, you can calculate with respect to total area also, but it is very much unbalanced, right? It is very difficult for us to calculate with respect to total area, right? But because for an elemental area, for a small area, when we consider a particular area to be a plane area, we calculate with respect to the area. Okay, so that is a, you can say, general thing we are doing with the fluid mechanics also, as well as with the flux also. So flux is calculated with respect to a particular area, okay, per unit area. Because अगर आप छोटा एलिमेंटल एरिया लोगे तो ऑलमोस्ट फ्लैट होगा, लेकिन आप बड़े एरिया पे जाओगे तो उबड़ खाबड़ हो सकता है, ऊपर नीचे ऊपर नीचे, तो आपकी एग्जैक्ट वैल्यू नहीं आएगी. तो हम लोग हमेशा जो डाइवर्जेंस लेते हैं हमेशा हमें छोटे एरिया के लिए लेते हैं, ठीक है ना. तो छोटे एरिया को अगर आप एरिया से मल्टीप्लाई कर भी दो तो कोई दिक्कत नहीं है, लेकिन जब बड़े एरिया पे जाओगे तो प्रॉब्लम आ जाएगी आपको. इसलिए हम लोग हमेशा छोटे एरिया पे लेके चलते हैं उसको, और इसलिए हम लोग उसको डिवाइड बाय एरिया कर देते हैं, ठीक है. So let us solve a few questions on the divergence. I hope that everybody has noted down solenoidal vector, right? This is important. Solenoidal, this word solenoidal. Sometimes I don't think whether it was asked in GATE exam or some other exam, but I guess in my semester exam, when I was giving third or fourth semester exam, so this was a question in mathematics, that if this is a solenoidal vector, then the divergence of this will be, so prove that the divergence of this will be equal to this. Okay, so because in semesters we have the proof and everything, all these things. Okay, okay, so I was talking about the divergence. Let us solve a question on divergence. And now let us understand about curl. Let us understand about curl, then I will tell you about some other things. Okay, now let us understand about curl, and then together we will solve the questions on divergence and curl. So curl basically tells you about the rotational properties. Curl basically tells you about the rotational properties. Now in fluid mechanics also I told you this thing, that it is rotational, but still when I finished fluid mechanics, some people were asking me, sir, does it mean rotating about the own axis, or does it mean rotating about some vortex motion? Now let me tell you a very important thing. Let us say that this is a river. Okay, with the help of this example you will understand it. This is a river, and this river is flowing in this direction. The river is flowing in this direction. I am showing you a top view of a river, not front view, but a top view of a river. So we know that in a river, if some of you might have swum in a river, right? If you know swimming, then you must be knowing that at the center of the river we have the highest velocity. At the center of the river we have the highest velocity, and as you go near the shores, near the banks, the velocity decreases. If somebody of you might be knowing swimming, then he must be knowing this thing. If he would have swum in a river, right, he must be knowing this thing. Okay, so at the center of the river we have the highest velocity, and as we go towards the banks the velocity decreases. Now let us try to imagine it. Let us say that you have a rubber tire. You have a rubber tire. Rubber tire means, देखा ना बचपन में जो वो डंडा मार मार के जो पहिया घुमाते थे, ठीक है ना. Let us say that you have a rubber cycle tire or tire of a wheel of a vehicle, okay, scooter or whatever, which can float on river water. Now do one thing. You put that particular wheel in at this particular place. Now this is your wheel. Okay. Fluid is coming from this direction, and we know that the velocity at this point is higher as compared to the velocity at this point. So this particular tire, just try to imagine it, this particular tire will rotate like this. It will rotate, it will move and it will rotate like this. Clear? You do the same thing at this bank. You put a wheel tire here, a rubber wheel here, okay. Velocity is very high here as compared to this portion, so again it will rotate in the anti-clockwise manner. It will rotate in the clockwise manner, it will rotate in the anti-clockwise manner. Clear? But when you will put a wheel tire at the center if you put a wheel tire, a rubber tire, so velocity at this point is equal to velocity at this point, so it will not rotate, it will move directly. Without rotating, it will move. The wheel will move without rotating. The tire will move without rotating. It means that for this particular, now if I consider this river, the river width as a vector field, I will say that the vector field is rotational. The vector field is rotational. In this portion, it is rotational. In this portion also it is rotational. But at the center, it is irrotational. So that is the meaning of rotational and irrotational vector field. So rotational and irrotational vector field means that if you will put anything in the field, it will start rotating about its own axis. Clear? Now there rises a question, sir, what is circulation or what is vorticity? So vorticity is 2 times of this movement is called as vorticity. Now what is circulation? Circulation is the average of rotational motions of a lot of particles. Let us say that now you have thousands of tires. Thousands of tires are this. On this side also we have thousands of tires, and this side also we have thousands of tires. These all tires are rotating in the clockwise manner. These all tires are rotating in the anti-clockwise manner. So if you just enclose it in a you can say surface like this, and if you calculate the total rotation, if you add the total rotation, the amount which you will be getting will be called as a circulation. So that is why, if you remember, in fluid mechanics I told you that okay, this is a thing, this is also rotating, this is also rotating, but about a particular common axis they are rotating together. The common axis means the average. That is the meaning of that, the average. Okay. So now let us understand the curl. So curl basically tells you about the rotational properties. It tells us about rotational properties. Of a fluid. For example, I am talking about fluid, of a fluid. Now what is this curl? So curl is the cross product. So curl of a vector, let us say f is the vector. F vector is how much? Let us say f vector is f1 I cap plus f2 j cap plus f3 k cap. The curl of the vector f is given by del operator cross f, and you know how to calculate the cross product. So we take a determinant. This is your I cap, j cap, k cap plus minus plus f1, sorry, not f1, del is dou upon dou x, dou upon dou y, dou upon dou z, and for this vector we have f1, we have f2, and we have f3. And with the help of this you can directly calculate the values. So I cap will be equal to dou by dou x of f3, dou by dou x of f3. I hope everybody knows how to solve a determinant. If you don't know, in linear algebra I will be telling you that. Dou f upon dou f3 upon dou x, sorry, I cap, no, sorry, y, dou y. Dou y f3 minus dou f2 upon dou z, minus dou f2 upon dou z, minus j cap. It was minus, so minus j cap, this and this, dou f3 upon dou x, dou f3 upon dou x minus this and this, so dou z upon dou f1, dou f1 upon dou z, and plus k vector or k cap, we have dou f3 upon dou x, sorry, dou f2 upon dou x, dou f2 upon dou x minus dou f1 upon dou y, dou f1 upon dou y. That is the curl of a particular vector. रट्टा नहीं मारना है इसका, बस ये समझ जाओ, वो आप कर लोगे अपने आप, रट्टा नहीं मारना है इसका, ठीक है, बस ये ध्यान रखो अभी ये चीज. Divergence is positive. See, divergence can be positive, it can be negative, right? So positive negative का ऐसा कोई डिफरेंट मतलब नहीं है इसमें, राइट? पॉजिटिव नेगेटिव का अब मेरे को देखना पड़ेगा थोड़ा सा, मैं आपको बोल नहीं सकता, बट हाँ पॉजिटिव नेगेटिव का जहां तक मेरे को आइडिया है ये डायरेक्शन से होगा, ठीक है, डायरेक्शन से होगा. फॉर एग्जांपल अ वेक्टर इज दिस, बट द नॉर्मल वेक्टर इज कमिंग आउट टू बी इन द ऑपोजिट डायरेक्शन. सो इफ यू डू द डाइवर्जेंस ऑफ दिस, राइट, इफ यू कैलकुलेट द डाइवर्जेंस ऑफ दिस, सो इट विल बी इन द ऑपोजिट डायरेक्शन. सो डायरेक्शन डाइवर्जेंस का पॉजिटिव नेगेटिव से मतलब है उसका, वो मेरे हिसाब से जो है आपका डायरेक्शन से होना चाहिए उसका, उसको ज्यादा मतलब नहीं होना चाहिए उसका नेगेटिव पॉजिटिव. इट विल बी जस्ट अबाउट द डायरेक्शन विच यू आर टेकिंग. ज्यादा आपको मैं एक बार देख के आपको बता दूंगा एक बार नेक्स्ट क्लास में, लेकिन जहां तक मेरे को आइडिया है इट इज अबाउट द डायरेक्शन ओनली, अदरवाइज इसका कोई ऐसे मतलब नहीं है इसका, इट इज ओनली अबाउट द डायरेक्शन. Okay, so that is the curl of f. It tells us about the rotational properties of a fluid, if I am talking about fluid. Now let us move forward, let us directly solve some questions on this. Okay, so find the divergence and curl of question. Find the divergence and curl of f vector is equals to x y z I cap I cap plus 3x square y j cap 3x square y j cap x z square minus y z square, x square z minus y z square, x square z minus y, दोबारा चेक कर लेते हैं, y square z k cap x z square, देखा लिखने में गलती कर दी, x z square minus y square z k cap at 2 comma minus 1 and comma 1 will be what? Okay, so in this question I will not give you options. Let us try to directly solve this question. First we have to find the divergence and then we have to find the curl of the vector. So solution. So divergence of a function f is given by del dot f. Del dot f, that is the divergence of a particular function. That will be equal to dou upon dou x of this f1, that is of x y z, plus dou upon dou y of 3x square y and plus dou by dou z of xz square minus y square z. So dou by dou x of xyz will be equal to y into z plus dou by dou y of, so it will be 3x square and plus dou by dou z will be equal to x, it was equal to xz square, right? Xz square. So it will be 2xz minus y square. At the points, which points do we have to find these values? At 2, minus 1, comma 1. So let me put the value of y as minus 1 into 1 plus 3 into 2 square plus 2 into x is 2 and z is 1 and minus 1 square. It will be equal to minus 1 plus 2 into 2 is 4 into 3 is 12 plus 4 and minus 1. 16 and minus 2 will be equal to 14, and 14 is the correct answer of this particular question. 14 is the correct answer. Let us try to find out the curl also. The curl will be what? So the curl of the function f will be equal to I j k, dou by dou x, dou by dou y, dou by dou z, and we have here x, y, z, 3x square y, x z square minus y square z, x square z minus y square z. So it will be a vector obviously, so it will be equal to I cap dou by dou y will be equal to minus 2y, and this will be dou z minus 0. Minus j cap will be equal to dou by dou x, it will be z square minus 0, okay, z square minus 0, and minus dou by dou z will be equal to x into y, and plus k cap will be equal to 6xy and minus xz. So it will be equal to minus 2y I cap minus z square minus xy j cap and plus 6xy minus xz and into k cap. Let me directly put the values now. So it is 2 minus 1 and 1. So it is minus 2 into minus 1 into minus 1 I cap minus z square, which is your 1 square, minus 2 into minus 1 j cap and plus 6 into 2 into minus 1 and minus 2 into 1 k cap. Okay, so now what we have to do is that it is now simple. So it is 2 times of I cap and minus 2, it will be plus, and minus 3 times of j cap, okay, and it will be plus minus 12 minus 2 minus 14 k cap, minus 14 k cap. Are you getting the same answer or are you getting a different answer for the curl? Are you getting the same answer for the curl? Okay, somebody is getting the answer also. Curl is 2i minus 3j and minus 14k. अच्छा चलो बहुत बढ़िया, आपका भी आंसर वही आया, ठीक है, good. Arish, yes, very good, Arish. Curl is Sharma ji is saying that curl is 2i सिर्फ 2i, कुछ ज़्यादा भी होगा ना. अच्छा हाँ, 2i minus 3j minus 14k. Okay, good. Okay, Gaurav has also got the same answer. Divergence 14. Okay, Sharma ji, divergence. Yes, very good, Sharma ji. Divergence is 14. Yes, curl is 2i minus 3j plus 14k. So A Sahu is saying plus 14k. Is it plus 14k? Let me check it again. Minus 12 and minus 2. No, it is minus 14. I think that you must have done some calculation mistake. It is minus 14 only. Next question. Okay, next question has been asked in GATE exam. Let me check it. X plus 3y, x plus 3y and x plus 3z. What is this? X minus 2z. कुछ गड़बड़ तो नहीं किया मैंने. X minus 2z. शायद ठीक है. ओके. Question is velocity vector v is given to us as x plus 3y I cap plus y minus 2 plus y minus 2 z j cap plus x plus az x plus a z k cap. If the vector is solenoidal, if the vector is solenoidal, okay, then the value of mod of A will be dash. What? The value of mod of A will be what? Curl 2i minus 3j minus 14k. Yes, very good. So velocity vector is given to us as x plus 3y I vector plus y minus 2z j cap and plus x plus az k cap. It has been asked in some GATE exam. Only GATE is written. Branch and year is not written. Only GATE is written here. GATE. Okay, so it might have been asked in some stream. So now let us try to solve this particular question. Solution. You try to solve it. Is again a simple question. You try to solve it. What will be the answer of mod A? So we have to get the value of mod of A. Mod of A. Another question is there. Curl of grad f. Curl of grad f is equal to what? Option number A 0, option number B 1, option number C 2, option number D can't say. That is the next question. Curl of grad f. That is, we have to find del cross del f. Del cross del f. First, okay, minus 2. See, if you are getting minus 2, good, but you have to put a mod on it, right? Because you have to get the value of mod. So the negative will be converted into positive, okay? So if it is minus 2, the mod of minus 2 will be positive, okay? If you are getting minus 2, it will be 2. Yes, 2, 2, 2, Sharma ji, 4, okay, पहले वाला 2, okay, yes, 2, 2, 2, okay, चलो एक बार check करते हैं इसको, simple है, right? Till then you try to solve this, what with the curl of grad f. So if it is a solenoidal vector, it means that the divergence of this function, the divergence will be equal to 0. If divergence will be equal to 0, I can directly say that dou upon dou x of x plus 3y, dou upon dou x of x plus 3y plus dou upon dou y of y minus 2z and plus dou upon dou z of x plus az will be equal to 0, because it is solenoidal, right? So it will be x means it will be 1 here, y plus 1 here, and z plus a here will be equal to 0, a will be equal to minus 2, but I have to get mod of a. So mod of a will be equal to 2. So 2 will be the correct answer. Zero, 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 zero. So that is a property also. That is also a property of curl of grad f. Okay, that is curl of grad of f becomes equal to 0 ultimately. With the help of some properties also you can prove it, or you can take the some function f. You can take the grad f. You will be getting it as I vector. Okay, dou upon dou x of f plus dou upon dou y of j and plus dou f upon dou z of k vector, and then you take a curl of it. If you will take a curl of it, it will be I cap, j cap, k cap, again dou upon dou x, dou upon dou y, and dou upon dou z. It will be equal to dou f upon dou x, dou f upon dou y, and dou f upon dou z. Okay, you try to solve it, then ultimately what you will be getting is that you will be getting 0 as the answer. Now the question is, sir, why is 0? I will be getting why is 0 as the correct answer is that even if you do not put it, even if you do not use it, so we have a property here. The property is that the curl of grad of s is actually equal to 0. Okay, in semesters, I still remember in semesters we used to prove this property also. In semesters we also used to prove this property, right? So you can remember this thing, that curl of grad of f will be equal to 0. You can also remember this property. It is a property of curl, that curl of grad of f is equal to 0. Now let us move forward. Okay, you can either prove it with this, or there is a property also with the help of that you can prove it. If you will again solve it, you will completely solve it, it will be equal to del y del fz, and this will be del fz and del fy, this will be equal to 0, minus j cap, this is del f del z, this is also del f del z, this will be equal to cancel out 0, and again here also it will be equal to del f upon del x del y minus del f upon del x del y, that will also be equal to 0. So ultimately you will be getting 0 as the correct answer. Now let's move forward. Okay, next topic is yes. The next topic is regarding the line integral. Next topic is line integral of a vector function. line integral of a vector. Line integral of a vector. Now the question is, sir, what is this line integral? Let me give you a curve. Let us say that this is some function. Let us say this is some function. And this is a closed loop. This is a closed loop. If you want to determine that, sir, how much is the work done? Sir, how much is the work done in moving a particle from this position to this position along this path? Now see my word, along this path, how much will be the work done in moving a particle from this point to this point? My answer would be, if you know the vector function, you do the line integral along this path and you will get the work done. You will be getting the work done of that particular function. So line integral basically tells us about the work done along a path. It is always calculated along a particular path. Now the question is, sir, what is the expression for a line integral? So line integral is represented as, let us say that a function is given to you, a vector function is given to you as f1 I cap plus f2 j cap plus f3 k cap. Then the line integral along a path, right, let us say along a curve C, this is your curve C, is given as f dot dr. And what is this dr? Dr is the space function, that is your dx I cap plus dy j cap and plus dz k cap. This is your vector function. So we have to do a dot product of this vector with respect to this function. So this thing will become integration along a closed curve C, f1 dx plus f2 dx and plus f3 dz, f2 dy and plus f3 dz. So this is called as a line integral of a particular function. Okay. So slowly we are moving towards the Stokes theorem, the Green's theorem and the Gauss divergence theorem. Okay. So in that particular theorem, so we know how we calculate how we can convert a line integral into surface integral, a surface integral into a volume integral and so on, right? But for that, before that, we must know that how to calculate a line integral, how to calculate a surface integral and how to calculate a volume integral. So basically this gives you the work done along a particular path, the line integral of a particular function. Note: if x, y and z are given in parametric equations, parametric equation means in some other variable, that is x is a function of t, y is a function of t and z is also some function of t. If this thing is given to you in some parametric equation, then the line integral of f dot dr vector becomes equal to integration along, okay. So that will be equal to dou fx upon dx into dou x upon dou t. Let me check it again. Yes, that is f of x of t into dx upon dt plus fy of a function t into dy upon dt and plus fz of t into dz upon dt. This thing I will be telling you with the help of one example, you will be getting it. So this particular thing has the concept of total differentiation, because this x is also a function of some other function, right? So this has a concept of total differentiation. We will solve one numerical, you will get it, that if something is given in the form of parametric equation, how to proceed with the line integral, you will get it that. Just write it down, then we will solve a numerical and you will get the idea how to solve a particular question if it is given in the form of a parametric equation. Parametric means in some other variable it is given. Okay, now somebody can ask you that this line integral, if you consider a line integral in case of fluid mechanics, if you remember, I told you in kinematics, line integral. So if somebody asks you, sir, in fluid mechanics, what is the physical significance of line integral? At that point of time when I was teaching fluid mechanics, I told you that line integral basically gives you circulation. Line integral, let us say that this is some velocity function, right? So line integral along a path gives you the average of, let us say this particle is rotating about this axis, this particle is rotating like this particle rotating, this particle rotating, okay? I gave you an example of a river, okay? And I told you that if you consider a particular area and along the curve, if you calculate the line integral, you will be getting the total circulation. Because in a particular curve, there might be, in a particular area, there might be infinite number of particles. To calculate the rotational behavior of each particle is next to impossible, because there are infinite number of particles. So which is rotating clockwise, which is rotating anti-clockwise, it is next to impossible. So what do is that we, along a particular curve, we take the line integral. So line integral in case of fluid mechanics, this line integral, it basically tells you circulation. Circulation means average rotation flow. Average rotational flow. In case of fluid mechanics, it tells you the circulation of a fluid. चलो आगे बढ़ते हैं, अभी क्वेश्चन सॉल्व करते हैं इसके ऊपर. जब ब्रेक चाहिए ना, आप लोग मेरे को टाइम बता देना, ठीक है ना? पता चला मैं ज्यादा पढ़ा दूं आपको, फिर आप बोर हो जाओ, ठीक है ना? तो बोर नहीं होना, अगर आपको लगे कि अभी ब्रेक देना तो आप मेरे को टाइम बता देना उसमें. Okay. Question. अच्छा, ब्रेक देना है आपको. चलो ठीक है, काम करते हैं. इट्स 3:45 नाउ, सो लेट्स मीट एट 4:05. Okay, let's meet at 4:05 and then we will continue with the question. Okay, so let's meet at 4:05.